Hello! Now we're going to look at how we can use the property or the law of the conservation of mass to say that the mass on one side of a reaction, the mass on this side, has to equal the mass of the other side. And when I say sides, I'm talking about a chemical equation where this is the reactant side, the mass of the reactant has to equal the mass of the product. And this comes from experimental data. It just comes from the fact that we've done plenty of experiments to find that when you are very careful, you can account for all of the mass in any normal chemical reaction. Which is very handy, because if you know what you put in, if you know what you put into the reaction, if you know what you put in, then you can predict what you're going to get out, because what you put in just has to be rearranged, and it ends up becoming what you get out, or what you get out has to be made up of the same things that you put in. Now they might be rearranged, they might be new molecules, they might be in a different state, but they're going to be the same atoms. You're not going to get extra atoms, and you're not going to lose any atoms. So when we're looking at chemical reactions, let's continue this scale analogy here, and let's say that if we wanted to make water, we'd have, maybe these are white, we have two hydrogens and an oxygen, okay, and these are bonded together. Well, that means that what we put in has to consist of two hydrogens, and we also have to put in one water. So they'll rearrange, and then this is what we will get. Our reactions will balance out. Mass-wise, we'll get the mass of the two hydrogens, and the mass of the oxygen will combine to make a molecule where they're stuck together. Okay, we got that point. Let's look at how we do this on paper. So if I say that I'm going to combine some number of hydrogen atoms and some number of oxygen atoms, they are going to combine, and they're going to give me some number of water molecules. Okay, so in this case, I'm starting out with what I'm putting in on the reactant side is, well, I'm putting in hydrogen and I'm putting in oxygen, and I'm putting in, well, this molecule of hydrogen has two hydrogens in it, so I'm starting with two hydrogens, and I'm also putting in one oxygen. Okay, so I'm starting out with two hydrogens and one oxygen, and what I'm getting out on the product side, well, there are two hydrogens here, two hydrogens. So hydrogen, I'm getting out two, and there's one oxygen. So this one has stayed the same. This is balanced. I have a balanced reaction by using one molecule of H2, one molecule of oxygen, and I'm getting one molecule of water. And that's nice, but it doesn't always work that way. So let's take a look at the example that we kind of brought up at the beginning of class. In our last video, we have some number of aluminum atoms, and I'm not going to write this solid because it's not important for this, it's just going to take up space. And I'm going to combine them with some number of oxygen molecules, and I'm going to get out a molecule that is Al2O3. So let's see what I start and end with. To begin with, on the reactant side, on what's going in, well, I'm going to start out with aluminum atoms, and in this case I only have one, and I'm going to start out with oxygen atoms, and there are two on the reactant side that going in, so there's two atoms here, so there's two. There's only one here, it's not written, so we know it's a 1. And I'm going to get out aluminum atoms, and I'm going to get out oxygen atoms. And what I'm going to get out, I'm going to have two aluminum atoms in this molecule, and I'm going to have three oxygen atoms. So two aluminum atoms and three oxygen atoms, and that's a problem because I only put in 1 aluminum atom and I got 2 out. And I put in 2 oxygen atoms and I got 3 out. So that doesn't work. That doesn't work. Okay, well, the aluminums are easy to fix because this is just 1 atom. I can just add another one. If I were to just put a 2 here, if I were to just put a 2 there, well, then I would have 2. This would already be a 2, and then that would balance out, right? My aluminums would work. I put in 2 and I'd get out 2. My oxygens, though, that's a little bit trickier. And the reason is 3 is not a multiple of 2. In other words, if I put in another atom, another molecule, if I put in another molecule, so that's a 1 now. But let's say it wasn't. Let's say I tried to put in a 2. Say I try to put in a 2 here. Well, then I'd have a total of 4 oxygens, right? I'd have a total of 4 oxygens. And that still doesn't get me to the 3. In fact, it's just as far, it's just the other direction. It doesn't get me to the 3. Okay? So something that I usually do, and it doesn't always work, is that when I see things that are odd, I usually will double them. Because an odd plus an odd, or 2 times an odd, will give you an even. So what I'm going to do is just to experiment, instead of this blue mark here, in green, I'll make it a different color. I'll make it purple. Okay, what if I doubled this? What if I came out with 2 of these? Well, now I wouldn't have 2 there. Really, I'd have 2 times 2, I'd have 4 aluminum atoms, and I'd have 6 of the oxygens. And that's beneficial because these oxygens here on the reactant side come in groups of 2. So using the purple instead of the blue, those are pretty similar, all I would need is 3. If I did 3 of these instead of 2, if I did 3, well, that's 3 times 2, that's 6, so then I'd have a total of 6 at the end there, and then my oxygens are happy. And the aluminum, again, easy to fix. If I need a total of 4 out, then all I need to do is change this thing to a 4. And one of the things we said in class was these are really good to do in pencil, because sometimes what you originally think it's going to be, it isn't. And it's just easier to be able to go back and erase than trying to scratch out and figure out which one you're working on. Let's look at another quick example. So let's say I have the chemical reaction of iron. I'm going to react iron, and I'm going to react it with chlorine, which is diatomic, which means it comes as a chlorine molecule attached, 2 atoms, two chlorine atoms attached together. And I'm going to make ferric chlorine, or FeCl3. And again, I want to ask myself, what do I start with and what do I want to end with? So here I'm starting with 1 iron, so I've got 1 iron and 2 chlorines going in. Okay, 2 chlorines. Coming out, zoom out a little bit. Coming out, I've got 1 iron atom. Well, that's nice. And I've got 3 chlorines, and I've got the same problem. I've got a 3 to 2 ratio. And it's usually easiest to just double this thing, just double this whole molecule. Say I don't just get 1 of them out, say that I do 2. I'm going to do this in red because it's easier to see. So I'm going to say, what if I make this 2? Well, now instead of 1 iron, this would become 2 irons. And instead of 3 chlorines, this will become 6 chlorines, which is even and divisible by 2, which means that all I have to do is have some number of these, and it should work out. So instead of the chlorines, what if I take this and I make them 3 chlorines? So I'm going to put 3 in there, which gives me a total of 6 chlorines coming out. And then, well, that just means I need another iron. So if I change that to a 2, then this is now a 2. And I'm writing this way, equals 2, because I'm not saying, I didn't say that I plugged in 6 of these. I'm saying that there were 6 total. I actually multiplied it by 3. So if you want to, you can say, maybe I'll do that, times 3 equals 6. Okay, 1 times 2 equals 2. And my last bit of advice is to not feel too frustrated. This is a very scientific and mathematical process, but it's also got a little bit of wiggle in it. It's got a little finesse, and sometimes it takes a few turns to get it to just right and make sure that it balances out. Just remember, don't change your subscripts. These must stay the way they are. They are the molecules they are for a reason. And you can just play with the coefficients to get how many of them will come in to balance out 2 to 2, 6 to 6, happy equation. A quick note for my in-class students: if you've made it through the module and you've gotten to this point in the video, for your homework assignment, please write the word pelican at the top. Doesn't have to be big, just write the word pelican, and I'll check it on Monday to make sure that you're following along with us.